Welcome to Altair Engineering Training and Support. In this video I am going to cover how to perform 1D meshing and side impact analysis. So I have a CAD model, a line CAD model in which the line geometry is there. Then I will show you how to create 1D meshing or 1D elements on this line data, roll case structure of line data. And then we will also see how to simulate 1D how to simulate side impact analysis using Radioss and Hypermesh. Then we post-process our result, that is we will view our results of displacement and stress and animation plot due to the side impact in Hyperview. So the baseline concept for the side impact analysis is I am going to apply a force of say around of 16,000 Newton on divided by on two different nodes. So if I consider 16,000, that means I am applying a force of 4G. So I am considering very high amount of force which is going to be applied on the side impact due to the side impact. And the reaction forces from the practical approach, I have come out that the reaction forces for the side impact are majorly due to the lower suspension pickup points. So I have constrained for all the 3 degrees of freedom, that is 1, 2, 3 stands for translation along X, translation along Y, translation along Z. So I am restricting all the lower portions to all the 3 degrees of freedom, that these points will provide the reaction forces. So I will follow the process named as MPCLL to simulate side impact analysis using Radioss. So we'll go step by step. First we create material as steel. We define the properties of material as steel. Then we create property for property collector for 1D beam element. In this I will create a hollow cross section using Hyperbeam, which is also embedded in HyperWorks tool. Then we update the component collector, which is available already available due to the importing of geometry. Then we create load collectors via force and constraint. So if you can see here, this is the forces I have applied. So I will create one different collector for forces and different collector for constraint. So we will create two collectors for forces and constraint. Then I will define the load step. So in load step I define the type of analysis I am going to perform. So this is the process I am going to follow. So I'll start my video by importing or by opening the HM file saved as IGS format. So either I can import the IGS file of a line structure, or I can save it in Hypermesh and open it in HM format. So as I have IGS file, so I will open it in IGS format. I will import that file in IGS format. So to import IGS file, I will click on import icon. And select the file type as IGS. Then click on folder option to browse the file from my folder location. So I will click on folder option. Then select the IGS file of a roll case line data and click on open. Then I'll click on import by keeping all the other parameters as default to import the IGS data. So in this way I've imported the IGS data of my roll case structure. Now I will follow the same process as MPCLL. So first I will create material collector as steel. So to create material collector as steel, I will click on material collector icon. Here I will enter to create panel. So I will select create radio button and enter the name of the material as steel. Select a different color so that I can view the elements through color option available in Hypermesh. Then I select type of the material as isotropic and a card image as mat1 to define the properties of the material as steel. And then I will click create edit to edit the properties of material as steel. Then to define the material, we want to provide value of E, nu and rho. So we define these values. Hypermesh by default pick the values of steel. If you have any other material, any different material, if you want to create a with a different material, you can simply put the value of E and nu here by just typing on it. So it will take that value and consider that material. Then click return to exit the card edit panel, and again click return to exit the material collector. So in this way you can see my material has got created. Now my next step is to create a property, but before property I will create a cross section to define the hollow cross section of my 1D beam element. So to define the cross section I will go to 1D hyperbeam. So select 1D page hyperbeam panel to define the cross section. In 1D select standard section. In standard section, select the standard section library as hyperbeam and standard section type as thin wall tube, and then click on create. So in Dropbox select hyperbeam as the standard section and standard section type as thin wall tube, and then click on create. So it will redirect you to a hyperbeam GUI. In this, as per the cross section of your pipe structure which you are going to use, you have to provide the inner and outer radius to create a hollow cross sectional for your hollow circular pipes. So I am going to provide an outer radius of 12.7 and inner radius of 11.2. So the pipe structure I am using having a outer radius of 12.7 and inner radius of 11.2. So by this my software automatically calculates the area of this particular cross section and all the other required parameters. So I again move to hypermesh to assign the property for my model. So to assign property, I'll move to hypermesh GUI again. I will click on this folder. I will click on this icon to again move into hypermesh. Once you move to hypermesh GUI again, you will find the hyperbeam cross section. One more panel is added to your model browser GUI. There you will find beam section that you have created using hyperbeam. Then click return to exit the hyperbeam panel. Now as per the MPCLL process, my next step is to define the property collector for the beam element. So to define the property, I will click on property icon. I'll select the radio button as create. I will enter the property name as roll cage 1D. Then select our appropriate color. Select the type as 1D because I am using 1D element. So I select the properties to be 1D. Then select the card image. We have different number of 1D elements available in hypermesh. We can create P bar as 1D element, P beam as 1D element, P rod, P tube, P weld. For this particular roll cage analysis, I am going to select P bar elements. The reason behind selecting a P bar element because they supports all the 6 degrees of freedom, and also they for say different cross section we can use unsymmetric cross section, also we can use bar element. So for the beam element, this is the best possible element type for 1D for this roll cage analysis. So I am using this. Then I select the material because I will assign the material to the property collector. So once I will assign the property to component, my material will also get assigned to all the elements. Then I define the beam section. So my software will recognize that what is the cross section of 1D element I am going to create. So I will select here tube section 1 and click on create edit to check whether it has taken all the required parameters or not. So it has taken the area and all the other parameters which is required to define a beam section, beam cross section. So it has already taken all the parameters. So I will click return to exit the card edit panel of property and again click on return to exit the property collector. So now again on the model browser you can see the property has been defined. Now my next step is to define or to update the component. So on my model browser, if you can see, the component is already defined. So now I will update the component with proper property collector. So to update component with proper properties and material, I will click on property collector icon, component collector icon. Select the radio button as update. Select click on comps and select the component which I want to update and click select. With property of no property, I will toggle it to property and update with a proper property, and then click on update to update this with a proper property. I will change the color of the component so I can view the meshing quite easily. Then I will move towards the next by creating the elements so that I can apply force and constraint on nodes and elements. So I will create 1D element using a line mesh panel available in HyperMesh, which is the most easiest and accurate way of generating 1D meshing. So I will go to 1D page, line mesh. I will select all the lines. So I will click on all. So it will select all the lines. I will click on lines and say all. So it will select all the lines. Make sure the line segment is whole line. Element configuration is bar 2. In bar 2 we have bar elements as well as beam elements, and we also define the property which I have created earlier. So all the elements will assign a proper property. Keep all the other parameters as default and click on mesh. So once you click on mesh, as you can see, the HyperMesh automatically start creating the mesh, and then click on return to accept this meshing. So in this way you can see my meshing has been generated. So from the model browser I will just off the surfaces or the line data to view only the elements. So here in this model you can view there are only elements, there are no line data available for this model. 1D elements are also represented through line, but in HyperMesh you have an option to view the representation of 1D elements in as a 3D representation. So to view those as a 3D representation, you can click on the 3D translation representation. So select 3D representation by the drop box. So once you click on that, you will find that you are able to view the elements in 3D representation. They are 1D, but you have changed the representation. You can mask the certain elements to check whether the cross section is assigned to it or not. So you can see you can go to mask panel here on top to see the elements. So it has assigned a proper cross section, as you can see here. If I again move it to traditional one and a 3D one, you can see for traditional it is line, but for 3D representation you can see it has assigned a proper cross section. Okay, so my third step has got completed. I have created elements also and updated the component also. Now I will move toward the next step, that is a load collector, by creating force as a load collector first and applying the force in this direction, and then we will create constraint as a load collector and apply constraint on the bottom location. So to create, I will first click return. So to create load collector for force, you can go to load collector icon, click on load collector icon, enter the load collector name as force, give him a different color to view the representation of force on the GUI itself, and click create. So once you click create, you will find the load collector has been created on your model browser named as force. Then we will apply this load collector as force on my model. So to apply load collector as force, that is to apply forces on your model, go to analysis, forces. To apply forces on your model, go to analysis, forces. For side impact, I am going to apply the forces on the front, on the main impact location, where once the impact will come, so the point where the force will transfer on the complete roll cage structure, there I will apply the forces. So during the simulation it will transfer the force. As you can see on my model, for the side impact, my direction of force will be X. So in X direction my forces are going to apply, as you can see. So I will select the direction as X, and pick these two nodes, which will be the first contact points for the side impact analysis, and enter the magnitude as 8000, as I am applying the forces of 4G on for the side impact analysis. So I will show you how the calculation is done and how I am applying 8000 Newton of force for considering 4G. So if I am considering 4G, then we will assume that weight of the vehicle is 400. Then the value of G will be 4000 Newton, and if I apply 4G, that means we are applying 16,000 Newton of force. As we are applying 16,000 Newton of force on two nodes, so we'll divide them equally, and we can apply a force of 8,000 Newton at each node, and for the whole structure it will be supplied as 16,000 Newton force. Then I will click create to create the forces. As you can see, the force representing arrows are very large, so we can change the magnitude or the size of the representing arrow. So in this way, on these two nodes, the forces has been applied in x direction. Now the next step is to apply the constraint on my model. So I will click return. Again, I will create one more load collector through which I can define the constraint. So I will click on load collector, and in load collector name I can put the name as SPC or constraint as per my convenience, because in industry people use SPC for single point constraint. So I will put SPC and select an appropriate color which will help us to visualize the model, and click create. So in load collector model browser, you will find in load collector one more load collector is added as SPC, which is single point constraint. Then I will click return to exit the load collector panel, and to apply constraint on my model I will go to analysis constraint. So I will click on analysis constraint to apply the constraint on my model. So as I discussed on this picture, that I am going to constrain the model on the lower suspension pickup points, all the 8 suspension pickup points at the lower side for all the 3 degrees of freedom. So I will pick all the nodes, select the create radio button and select the nodes, and select the suspension pickup points. These points may vary from model to model. So if you have some different model, so these points may get changed. So for my structure, the suspension pickup points are these. Maybe for your structure the suspension pickup points may vary. So I have selected all the 8 suspension pickup points, the lower side of that, not the upper ones, and select the degree of freedom 1, 2, 3. The degree of freedom 1 stands for translation along X, degree of freedom 2 stands for translation along Y, and degree of freedom 3 stands for translation along Z. So I am restricting the translation along X, Y, Z axis, because these are the reaction forces comes on my roll cage structure. Then I will say create to create this. As the represented triangles, the constraints are represented using triangles in hypermesh, are very small, so I can increase the size of the representation triangles. So if I view the complete model, I can easily view the representing triangles. So as you can see, I have applied a constraint of and restrict the degree of freedom 1, 2, 3, that is translation along X, Y, Z axis, and I have applied a force of 8000 Newton on each node, so a total of 16,000 Newton in X direction. So my next step now is to apply the load step, to create a load step to define the type of analysis I am going to perform for roll cage analysis, that is side impact roll cage analysis. So to create a load step, I will go to analysis, load step. Then I will change the name as side impact. Select the type of analysis as linear setting. Check the box in front of SPC and load. Click on is equal to sign and select SPC. And on front of load I will select force and click create. So on my model browser you can see my load step has been defined. So my process has been completed for the analysis, that is I have created material, I have created property, I have updated component, created load collectors and assigned them, and created the load step. So all my MPCLL process has completed. Now my next step is to save this file and run the analysis using Radioss. So I will save this file, creating as side impact analysis folder, and save this file as side impact. So my file has been saved in the appropriate folder location. So all the during the analysis, the files, the result file which it will generate will be saved in a single folder, and I can use it for the further process. So I will click on to start the solver. I will click on analysis, Radioss. I will use Radioss as a solver to solve this side impact analysis. Then I will click on Radioss, select the export option to all, run option to analysis, and memory option to default memory. Save the FEM file on the same location where I have saved the HM file, and click on Radioss to start the solver. Once you see the message as analysis completed, so my process has completed and my results has been generated by the Radioss solver. Now I will click on results to view these results of displacement and stress due to side impact in Hyperview. Also we will see the animation plot in Hyperview, that how due to the side forces how my roll cage is going to animate or deform. So this is the Hyperview GUI. So first of all, to view the displacement plot, click on contour and select the displacement, result type as displacement, and say apply. So this is the displacement due to the side impact. If you want to see the exact displacement on which node, on which location the maximum displacement is coming, so you can click on measures, static minimum and maximum, check the box for static minimum and maximum, deselect minimum and make sure the maximum is selected, so you can see the maximum displacement is coming as 51.03. Now again go to contour and select the elemental 1D stresses and select axial stresses and say apply. So now you can see the maximum stresses are coming as 115 Newton per mm square in this bar. So in this way the analysis for the analysis point, the side impact is giving the analysis as 115.860 and the displacement is 50 mm, around 50 mm. Also we can view the animation plot. So if I lower down the speed, you can see, if you click on the play icon, you can see the animation plot. So in this way my roll cage is going to behave due to the side impact, due to the force through side impact. If you are a Windows 7 users, you can also have one more option, that is a sniper tool, so through which you can capture the images of the different modes. Or we have one more option available in Hypermesh to capture the images, that is capture image, capture graphic area, capture panel area, capture dynamic rectangle, capture frame area, capture graphic area window, capture dynamic rectangle video. So if you have an animation, so you can capture this animation on here and save this file as animation and use in Hypermesh, or you can use in your presentation, so that I will show in where. So this is the folder location where I have saved the animation file. So if you double click it, you can view here. So to view the animation plot, or you can use the same in PPT, you can click on the setting option, change the frame rate type, select the number of steps, say to be 50, and then click on apply. So you can see this is, or it will capture the complete graphic area. So what you can do for the result point of view, you can select this and off this one and click on this and only select the dynamic area where you want to click. So just click on this video. So till the time you are clicking, it will start recording it, and then it will save the your animation plot. So keep on click on, then it will capture this and then it will save it. Once you release it, it will save. So I will override this and say yes. So it's processing my graphic video, and if I go to side impact folder and see the animation, so you can see here, this is the animation. So if higher is the max animation plot, you can simply put this in your PPT. So in this way you can also capture the animation plot. So in this way we have ended with this video, in which I have covered how to perform side impact analysis along with the how to generate 1D elements and in role case structure, and how to perform side impact analysis.